Do you guys have any solutions to help automate some of that? Or what is the process of actually mocking my API?
Yeah, that's a good one. I think a lot of people are struggling with actually creating sufficient mock set for the application or for the existing test cases. For a very long while, we didn't have any way to create the mocks because very often people would want to create them from, let's say, runtime behaviors. And I wasn't a big proponent of that because maybe you have bugs in runtime behaviors. It would be nice to have some kind of higher ground, maybe an API spec. That is the right source for your mocks. And then I think a couple of years back, we unveiled the source library, which is basically another package in the ecosystem that can work alongside MSW. And what it does, it accepts different formats of your network, and it generates request handlers that you can then feed to MSW to do the mocking for you. And right now we support OpenAPI. So great, if you have a spec ready, you can feed it to source and grab the handlers from it, which is very nice. And we also added support for network archives for A files, mostly for debugging purposes. I think I have a video on YouTube, which is like a short use case where I have a bug in the browser, and it's a tricky bug. It doesn't happen all the time. It's intermittent. It's hard to reproduce, but I caught it in the browser. And what I want to do now, I want to grab this state of the network and put it alongside my test. So I can run my test and my potential fix along this very thing that happened. So what I can do, I can export this network from the browser into archive. I can put this archive next to my test, and I can provide it to the source library. So now I have this snapshot of the network working reliably through MSW to verify, hey, I'm actually fixing this. And I think is a really cool use case. So these are two primary ways how people can do generation of mocks. There's also a few just user-led solutions. I think there were a lot of them actually over the years because people are tired of writing the mocks by hand. So there are some related to network archives, some for OpenAPI, some for even like more targeted third-party libraries. I'm trying to recall. Yes, Pact, of course. There's Pact. So if you have a contract testing done by Pact, you can also use that to have mocks from this. So I think people built, I think, considerably enough tooling around it. And I'm also looking forward to exploring more inputs to the source library.
Something I was just thinking of generally, like if you replace is the interceptor level like customizable? Like, so I was thinking like, oh, this is great. Like, this is a fantastic tool for the Node ecosystem. I wonder like what it takes to spread this to like the Dino ecosystem or the Bond ecosystem. I mean, like, there's just some internal differences there, obviously. Is like the interceptor part of it something that can be replaced? Is it like designed in that way?
So speaking of MSW, you can create your own setup class and you can use different array of interceptors there. And this was actually one of the issues we discussed recently on GitHub with one of the contributors. They wanted something else. Like they said, like we written our own interceptor for our thing. It makes sense. How do we plug it in? Like we want it in MSW. So what you can do, you can create your own class. You can extend this existing base class so you have all the experience from MSW, but you can provide your own interceptors array. And you can do that through this low-level library that I mentioned. You can pretty much implement it yourself too, but I think it provides very nice starting ground, being able to apply the interceptor, dispose of it, append overrides, and all of this. So yeah, you can do that. I don't know if it's like the best strategy to account for different environment differences, but it's something to explore. I'm trying to build in general APIs that would be composed much as possible, from MSW to how you can compose resolvers and all the routing logic to this low-level things like interceptors. It is not very common, for better or worse, but you can definitely do that, and it's very often a byproduct of API design, which I think is nice to have.
So I was going through your docs last night, and they are just beautiful docs. You can definitely see that you have a root in graphic design because even all your blog posts have a nice little illustration along with them. One thing I noted, though, was that the recipe section is huge, and there is so many different situations where you can use mock service worker. Of those, what was some of the hardest ones to support? You support GraphQL and WebSockets. It seems like that's going above and beyond the initial value proposition that MSW is.
Yeah, there's a lot of things, a lot of like particular scenarios. Some of them brought by people using the library, some of them just something I wanted to have for a long time, like WebSockets. What was the most difficult to support? It'd probably be WebSockets. It took 4 years, not of active development, but like 4 years of constant consideration and thinking and brainstorming. And I think it's very nice. We finally announced the official support last autumn. So now people can also mock WebSocket APIs, which is a new protocol for us, but a very nice addition. I definitely like the streaming support. This is my favorite. I think a lot of developers are discovering streaming on the web like last year and this year. And with things like LLMs and AI application, it's going to get more popular. And it's very nice that you can mock streams in MSW just in the most elegant way I can think of, because it's just web APIs. There's nothing from MSW. You just create a readable stream or a transform stream. I actually have a very nice lesson on Egghead that I absolutely loved making, where I showcase how you can intercept a video stream. Let's say if you're building your own Netflix, and you can transform that stream in any way you want. So you can feed it to some video transformer if you want. Let's turn it black and white. Why not? But what I did, I showed how to insert latency between stream chunks, so you can actually test the loading spinner. So you're streaming from a low bandwidth connection, and now you want to test, hey, my app should show I'm buffering, I'm trying. And that's how you do it. You just intercept a stream, pipe it through a transform stream, and then respond using a fetch API response. Very little MSW, and this is what makes it beautiful.
Latency tests are super powerful. That is really a superpower. It's like just being able to inject latency in your mocks in particular. It like tests a lot of pathological cases. What are some of the details that are hard to get right when you're building something like this? I mean, you've got so many layers. You've talked a lot about composability of the software. You've talked a lot about like inserting yourself at the right layer of abstraction. What is your sort of approach to maybe new features or how you think about adding things to MSW?
Yeah, that's definitely a great question. I think I was very lucky slash, I'm not sure, considerate at the very beginning when every core aspect of MSW was designed, that it turned out into this posable thing. At least for me, as somebody who develops and adds things and tries to improve things over years, I always take like the seamlessness into like high regard. It always on my mind whenever there's a new API. I'm trying to think how to implement it so it affects as little as possible of your code. I also absolutely love the paradigm where mocking should actually resemble the way you would work with this API. So if you, for example, creating a fetch request on the web, you call fetch, or maybe you construct a request instance, provide it to fetch, you receive a response instance, and that was in the foundation how we designed MSW 2.0, which is completely fetch based. And I love it because that's how people make requests on the web, and that's how they should ultimately mock them. There shouldn't be any custom abstraction sitting in the way of you requiring to be learned. It's just regular JavaScript, which I think is the theme of a lot of my API decisions here. And this goes also to other protocols like WebSockets. So when we design WebSockets, it's obviously very different from HTTP. From the way you create these connections to how you handle them, it's all event-based. There is no definite way of handling an event. You can just receive events, you can send events, and that's it. And this was also very important to reflect in the API that we got, which I always try to be inspired by the standards that we have, like how is it working there? How do people interact with those standards? Or in case of like where maybe not that many people use the raw WebSocket class, I was looking a lot at third-party libraries like Socket.io and WS as well to see how they nail it, like what kind of experiences are familiar to people. What would they expect when you work with WebSocket? How would you mock that WebSocket? So if I can strike this resemblance, this always leads to a more clear API. So to me, this is really important. From composability point of view, I think I try to make things do, again, as little things as possible, because there were a lot of situations over the years where people wanted something like, can we have a base URL option in MSW? Like all our requests are against this defined host. Can we have a base name? And yeah, it sounds like an appealing thing to have, but I always said, if you want to have base name, just do it yourself. Create a utility that's called, I don't know, with a base name or to our, like any way you want to call it. And it will just accept the URL or a path portion of the URL and just rebase it against your base name. I think that's a really good way forward. I think this is how people should perceive third-party libraries. They shouldn't do every little tiny detail for you, but they should give you enough tools so you can achieve those tiny details if you want to. Because MSW is very flexible, maybe to its own demise, that you can have a path matching by a string, by a full URL, by a regular expression. And it's very hard for us to give you an API where all of these will be matched against the base URL because MSW doesn't know. But you do know. You know that you're making, let's say, requests using string paths. So it's very easy for you to handle this and say, yes, my utility won't support regular expressions. I'm good with it. So this is something that's tricky to get right, but saying no and like knowing where to draw the line is very important for API design so it doesn't get into this bloated monstrosity that's very often the case with projects. And that's not their fault. It's just what people want. And then you obviously want to please. You want to make sure your tool does the things people want it to do, but it's also your responsibility to know when it shouldn't do something. And I think that's contributed a lot to how MSW is today. And I think it will contribute a lot to what it will be in a few years later as well.
Those thoughts remind me of another blog post on your blog where you have lots of opinions on patching globals. And it seems like it's another thing where it's, oh, I want this API and this thing is right here. And it seems like it would be a nice, easy thing to work into my API design, but usually goes wrong. Can you share some of your thoughts on why we shouldn't be patching globals to implement APIs?
Absolutely. Yeah. This this is a very touchy topic, definitely to me, as somebody who's been working with globals and patching globals myself. And then I realized that, yeah, that's a bad thing to do. And I wrote this piece on my blog to highlight this problem a bit better, because it seems like not everybody, which is fine, because as a consumer of different projects, different utilities, so you want, for example, your fetch function to have some special property that would make your life easier. But there's so much more to consider, especially behind the scenes, especially in the whole ecosystem, that I thought that it would be a good idea to highlight this. The main point is that you don't generally modify things you don't own. And this is how you get a very stable code in terms of your influence on the environment. So I think that was a series of tweets back then where there were a few APIs by Bun and some APIs by Next.js, and also some APIs from React, that they all had something in common. They wanted to modify existing globals. There was fetch modifications and a few other things. And it was out of place because it would break a lot of compatibility. And to me, like, the educational aspect of it all was very much hurting, because you're raising generations of developers who would think that these APIs actually work like that. And the moment you set foot outside of that framework or outside of that environment, suddenly they don't. So it just didn't make sense to me. Why would you invest your effort as a consumer and as a library author into creating this problem when you can avoid it? And luckily, this wasn't just me. A lot of really great developers shared this perspective, especially from those teams that I mentioned. So people listened to the feedback, people adjusted those APIs. So for example, caching from Next.js was just moved outside into a nice declarative API. And I think that's the way to go. Yeah, definitely not a good idea to patch globals. To anybody who wants a bigger picture, you can go to my blog and read about it. There's also a very nice, famous piece from the incident with MooTools, how they patched the global. And it turned out that now we cannot have this nice API. Everybody just misses on it because of adoption, because of a ton of factors to consider. You cannot just be looking at developer experience in isolation. There's much more things there.